So really, if you just know the equations with E in them, you can pretty much figure out the rest of the equations.
Yep.
If you want. Okay.
Because I'm giving you the equation. You need to prove it.
Ah, okay.
So now you flip this. So we know that the cosine is going to be given as e to the x plus e to the negative x divided by 2 plus e to the x minus e to the negative x divided by 2.
That's what I do when I make the ratings also in the GMP environment. Make it look like the actual letter.
Just go over it like.
But yeah, no, it's just worse for me because like I get reviewers and do it.
Oh my god.
Force of habit.
So you see that these two will cancel because they are positive and negative e to the negative x, and you have 2e to the x over 2 equals e to the x. E to the x equals e to the x. All right, let's do the fun one. Two sine hyperbolic of ln of secant x is equal to sine x tangent x. So this one is mixing hyperbolic with the trig. All right, so no pressure. You have 18 seconds. Let's go.
The answer's Tuesday.
The answer is Tuesday. Love it. All right, let's take a look at this. So this is a triple, on the left-hand side, you have a triple function composition, right? Secant is plugged into ln, plugged into sine hyperbolic. So it is, it's interesting. So what do we have? Well, I'm going to write the definition here, and I'm going to use a flower instead of x. So sine hyperbolic of a flower is equal to e to the flower minus e to the minus the flower divided by 2. Why am I using a flower? Because I want to signify that this thing could be x, or could be a flower, or could be 7, right? So whatever is here gets into these. It's the argument of sine. So when I write this out, I get 2. Instead of sine hyperbolic, I'm going to have e to the ln of secant x minus e to the minus ln of secant x, everything divided by 2. Now 2 and 2 will drop. E and e cancel. I get secant x minus, and now I have e to the ln, and then this one, secant x gets to negative 1. 1 over secant x is cosine x. So this becomes secant x minus cosine x. Now we need secant times tangent. No, we need sine times tangent. So now secant is 1 over cosine x minus cosine x, and I'll put over 1. So we multiply over here by cosine x over cosine x. Actually, I'm going to put this orange, so because it's a common denominator thing that I'm looking for. And I have 1 over cosine x minus cosine squared x over cosine x. So this is 1 minus cosine squared x over cosine x, and that is sine squared x over cosine x, which I'm going to break into sine x times sine x over cosine x and sine x tangent. Guys, Thanksgiving is coming up. This is an awesome problem to kind of lead into the festivities. As you can see, it's equal to sine x tangent x.
I don't understand why, like, so when you first put the ln into the exponent, I know that the first one cancels out to secant x because
E and ln are inverse, yeah. The second one has a minus, so you can't cancel the second one because of that minus. So you have to use that formula that you learned in for ln's, where it says p ln x is equal to ln x to the power p. So you actually have a negative 1 over here as p. And you get that negative 1 and ship it inside as the exponent of this, and you get secant x to the negative 1, which is 1 over secant x. 1 over secant x is cosine. So that's how from here I went there. And then e kills ln. Yes?
You had negative 2 ln's, can actually be secant squared? No.
It will be secant squared, it will be cosine squared eventually, yes. Yes. If this was a negative 2 over here, it will go in as a negative 2, and then it will create and sine cosine squared.
Can you go back to the bottom?
Sure.
Please.
That's the tons of fun. These are called hyperbolic identities. You have that blue list of 12, and probably pick one of those for you to convert into ease, and then you just, go and shovel the algebra to show that left side equals the right side with a small.
So you're not able to something like that.
Oh, it's the same.
I wrote the problem out wrong when I did it. I actually thought it was that.
Me too, I wrote the last one wrong. I only put the minus and the plus. Yeah, it kind of ruins the day.
Well, no, I threw an X in between the.
Oh, you threw in one extra x? Oh yeah, that would ruin the function composition, yes.
Yeah.
It would change function composition to function multiplication, which definitely ruins your day. All right, so that's part one of hyperbolics, where you guys see all of the trig, right? Like components, right? So function components of it, and identities at the end. And now is the time for us to do some calculus, this being the Calculus2 class, right? Which means the next section of this is going to be on, the next section here is on calc of hyperbolic functions. For calculus, if you are using limits, you will look at the graph to obtain the y value, because limits compute y values, so you should be okay. We are mainly focusing on derivatives and integrals because they are what we use most of the time. Now, we are going to have 12 of these formulas, because you have 6 functions for derivatives and the 6 functions for integration. The coolest thing about this is they're the same as the trig. You just need to make sure that the minus signs are in the right spots. That's all. So if you learned at one point in your life that the derivative of tangent is secant squared, you know that the derivative of tangent hyperbolic is, and here's the bad part, negative secant squared this time around. So we are going to recycle 100% of your trig formulas that you already know, and we're just going to reassign some minus signs and move them around a little bit. And that will be all. So here we go with the first one. The derivative of sine hyperbolic x is cosine hyperbolic x. And immediately read that backwards. Integral of cosine hyperbolic x dx is sine hyperbolic x plus c. So this is 2 out of 12 already. If you are to delete these ages, you will have exactly the trig formula you know. The next line is the cosine hyperbolic x, so the derivative of cosine hyperbolic x is going to be sine hyperbolic x. And this is where the difference creeps in, because the derivative of cosine was negative sine. So no negative now. Integral of sine hyperbolic x dx is cosine hyperbolic x plus c. Again, no minus sign. Okay, so the next one is going to be the derivative of tangent. The derivative of tangent hyperbolic x is going to be secant hyperbolic squared, and integral immediately is going to be integral of secant hyperbolic squared x dx will give you tangent hyperbolic plus c. So guys, these are your positive ones. And then the next three will all be negative. So you have your sine, cosine, tangent, derivatives, integrals over there. No negative signs anywhere. Now we have the derivative of cotangent hyperbolic x that gives us negative cosecant hyperbolic squared x, and that will now also spawn the negative on the integral side. So integral of cosecant hyperbolic squared x dx is going to be negative cotangent hyperbolic x plus c. Final two, the derivative of secant hyperbolic x is going to be negative secant hyperbolic x tangent hyperbolic x. So this is the one that did not have negative in trig, but it has it now. And the integral of secant hyperbolic x tangent hyperbolic x dx is going to be negative secant hyperbolic x plus c. And the final one is the cosecant. Cosecant hyperbolic x is going to be negative cosecant hyperbolic x cotangent hyperbolic x. The integral of cosecant hyperbolic x cotangent hyperbolic x dx is negative cosecant hyperbolic x plus c. Now this is a good paparazzi shot right here for you guys to be able to pull these up on your phone, right? Images right off the bat. So it's good to take this photo. The Wi-Fi is in and out and in and out and in and out. It's constantly lagging. Okay, so now that we have seen that these formulas are practically the same, the way you guys are used to for trig, just have to be careful that the minus signs now, I mean, you still have your cosecant and cotangent had minus signs. The secant one is new and the cosine lost it. That's the swap. I'm going to work on the very important fix for these formulas. Because these formulas are only for x, right? What do you have most of the time? Not x. You have 2x, or x squared, or some modification of that, right? So I can pick on, let's say, secant x. So I'm going to just go like this and say fix. So now what is the fix like? Swap x with any function f of x. Now, on the derivative side, that means chain rule. On the integral side, that means u sub. And 90% of the problems, 95% of the problems are always that stuff, rather than the basic one. So, the derivative one, which is now secant hyperbolic of f of x, meaning x squared or whatever else you put in there, is going to give you negative secant hyperbolic f of x tangent hyperbolic f of x times f prime of x, because that's the chain rule. So if you don't have x, but you have some function instead of x, anything other than x, we are using the formula where each one of those x's is replaced with the f, obviously, and then you have the chain rule piece at the end. The integral formula must have f prime of x and then secant hyperbolic f of x tangent hyperbolic f of x dx to give you the answer of secant hyperbolic of f of x plus c, which is the u sub, where u equals f of x for u sub. So that's the fix. And now you apply this fix to all 6. I mean, I applied to 1, so other 5. Replacing every x with f of x. And then for derivative, it's going to be times f prime. And for integration, you used u sub. So let's do examples of this to make sure it makes sense. So we'll start with some, let's go some vanilla problems. Say you have the derivative of tangent of x cubed. Right, the derivative of tangent of x cubed. So it's a chain rule. It's no longer x, it's x cubed. I could have put x cubed plus 1. I could have put 1 over x cubed. Doesn't matter. Whatever this function is, we'll deal with it. Now,
Not hyperbolic?
Yeah, it is hyperbolic. Thank you. I was just testing if anyone is paying attention, so I know you are. There you go. So derivative of tangent is secant squared hyperbolic. So we have secant hyperbolic squared, and then you have your x cubed, because you see that you get to keep the same function inside, because this f of x is the same as this f of x is the same as that f of x, right? They're all the same. And now times 3x squared, because that will be the chain rule. So 3x squared secant hyperbolic squared x cubed is the full answer to this one.
That easy. Like that was
You know this is math, right? And our collective opinions don't matter. Feelings don't matter, opinions don't matter. Just that there is a rule. That's what makes this stuff cheap. Yes? You got it? All right.
Can you just move the screen up to show the last part that you wrote for the...
On the blue one?
Yeah. So, I'm confused about the insert of the chain rule. Like, I'm confused about where that came from.
No, well, it's a derivative formula. So tangent, it's right here. But instead of x, I'm using f of x. So I have to multiply by the derivative as well.
Oh, okay. Oh my God. Okay. Thank you.
You're welcome. Let's do another example for derivative before we jump into integrals. So how about you said something simple, not too spicy. So how about we go with x squared times cosine hyperbolic of 3x. That should not be too spicy. Really? What do we have in this problem? Very good. Which one is the boss? Product rule is the boss. Good. So product rule is the boss in this one because I have a function x squared times another function. So this is a product rule problem where we have the chain rule with a hyperbolic function there. So if you recall, the product rule was this is u, this is v. You have uv prime plus vu prime. So let's go. Copy the first one, which is x squared, times the derivative of the second one. Derivative of cosine hyperbolic is sine hyperbolic 3x. And then we have to multiply by 3 because that's our chain rule for this one, because it was not x, it was 3x. Plus, copy the second one, which is cosine hyperbolic 3x, times the derivative of the first, which is 2x. So here we go with the u, v prime, plus v, u prime. Remembering Calc 1 product rule. So now I have 3x squared sine hyperbolic 3x plus 2x cosine hyperbolic 3x. And that is it for derivative side for about 6 seconds, because we are about to do integrals, and integrals will have u sub, and u sub will have derivative anyway. So yeah, it's like you think you're gonna escape. No. So. Right. So let's start with the vanilla example over here. What is the integral of cosine hyperbolic of 6x dx? right? So that would be a vanilla example.
This stuff is on the exam, right?
Exam 1, yes. Which is this is the last section, because it's chapter 67.
It's a lot of
You should know all those.
I remember
There's nothing else, just the minus sign.
Cosine.
Cosine secant equals minus sign, that's it. Everything looks the same. Derivatives, anything.
Yeah, I was wondering how that if they have the same cycle, but it just goes back and forth between cosine and
Yes.
sine, no negatives.
No negatives, so they have different cycles.
Also, New Jersey debate whether or not it's the Taylor series or the Four. Yeah, go for it. Like South Jersey might have a Four series.
We have to wait.
Oh, it's so good.
Well, it was like 5 people who can tell that. Like, that's it.
I feel like there should be studies made. You could probably sell those around the college.
Nah.
Corporal series.
You have to understand.
Oh, sorry, not left to right again.
But you have to understand that the only 1% takes out. So your margin, right? Everything you will make money in advertising assets, not to 60.
But then you get that weird inflation where like one person sees someone popular, so like a streamer's wearing it, and they have people try to get the joke, and want to copy that joke. So now people have to understand the joke to be able to explain to people who don't get the joke why the shirt's funny, and then it takes off.
It's the same thing when
I mean, that's a
when I
1%
wear my
chance.
red shirt that says this shirt is blue if you run fast.
I was literally just gonna say that.
Another Half-Life thing also.
I have to explain it, exactly.
I remember last semester.
Yeah.
Yeah, last semester you wore it, and I was like, I don't get it.
So yeah, it depends on how fast you move.
What about all the other, like the power reducing, doubling, stuff?
That's given to do the proof.
Is that like fair game for the?
That's given to do the proof. So it's gonna be on the paper.
Okay. We're not gonna have to like apply it to do.
Sorry to disappoint you.
Okay.
What?
Thank you.
So the answer is sine hyperbolic 6x over 6 plus c, and then we're done, right?
Oh, that's right.
Yeah. You forgot, that's -1. Don't worry about it.
I mean, I'll worry about it. It's one I need.
If you forget to know 10 problems plus c, then it's just going to be minus 10, and it's just 1 grade down. But it's still A because you did all 7 quizzes. That's 107 minus 10, 90, right? 97. So there you go.
I did all the quizzing.
Well, the first one is tomorrow, so. All right, let's see a little bit spicier over here. How about integral of sine hyperbolic to 93x cosine hyperbolic x dx?
Oh.
What should we do there?
Why do we divide by 6? Why do we divide by 6?
Oh, you can use it as a u sub because it's not cosine x, it's cosine 6x. So when you do the u sub, you will have u equals 6x, du will be 6 dx, and then there's that extra 6 that you need. What's the trick for this one? U sub. Great. What's U? Sine hyperbolic. It's identical to what we had before. Cosine hyperbolic x dx. And we go and say integral of u to the 93 du, which is u to the 94 over 94 plus c. And then I don't care about u, I care about the x. Sine hyperbolic 94 x plus c. All right, one more. Integral of tangent hyperbolic x. Why, disappointed? Because if I put a cube over there, you're not going to like it. Tangent is not a basic integral, right? So how do we solve this one?
Rewrite it as sine hyperbolic x over cosine hyperbolic x and change it to e.
We're not going to change it to e. We can use u sub from there with the sines and cosine. So the first step is to change this to sine hyperbolic x over cosine hyperbolic x dx, and then use the u sub right there. So it takes some time to practice this. U is cosine hyperbolic x. You can't leave the du to be in the denominator. It has to be on top. So that's why you pick cosine. And then the derivative is sine hyperbolic x dx, which is perfect because both are on top. And you are having now the integral of du over u. And what's the integral of that?
Natural log.
Keep talking.
E. Oh wait, natural log absolute value.
There we go. This is how you upgrade. So I guess 3 of you get to do the exam together, right? Keep upgrading the idea, and then you're guaranteed to score 100. I'll split it evenly between everyone. So
I'm confused about why it's not just secant squared.
the derivative of tangent is secant squared, not the integral. So we have ln absolute u plus c, which is going to be the ln of the cosine hyperbolic x plus c.
In the book, it doesn't even have the absolute value for cosine x.
You don't need for cosine because it's always above, but if you are to do the cotangent, the hell breaks loose. So we're always going to have it. In this class, you will see that in some cases for your section 8.5, eventually you're not going to need absolute values, but then for every case in chapter 11, you are going to need absolute values. So you know what, just put absolute values all the time. That's integration. Should we do another one, or are we good to take a break, and then when we come back, we talk about integration anyway. 8.1.